designed to help patients stop smoking, which is coincidence. 198 patients were given sustained care, and 82.8% of them were no longer smoking after 1 month. Use a 0.01 significance level to test the claim that 80% of patients who stop smoking when given sustained care. Does sustained care appear to be effective? Well, let's see. Let's go back to the problem and see what we got here. So, 198 patients were given sustained care. So N is 198. If you want, I'll underline. Right? We're given sustained care. 82.8% of them were no longer smoking after 1 month. This is my stop smoking. This is my success, right? Well, but here's the thing. I don't know how many out of the 198 were no longer smoking after 1 month. I just know the percentage out of 198. So therefore, in this example, they give me p hat instead of x. I have to determine x myself. And if I'm using the calculator trick, I'm going to have to calculate x because that's what it asks me for. So you see the difference between the different kind of scenarios. Like this one says, this is my sample size, and out of that, this many had successes. This one says, this many were this case, this many were this case, this is the total. This one says, I had 39 smoking 1 year after and 32 not smoking 1 year after, but it doesn't give me the sample size. But this one says, I have 198 patients, and this percentage of them were no longer smoking. That's p hat now given to me. So I'll find x in a second. Let me finish this off. Use a 0.01 significance level, that's my alpha, to test the claim. I hear a claim. Let me write my null and my alternative. A claim about a percentage of a population, a claim about P, a claim that exactly 80% of patients stop smoking when given sustained care. So that's not more than, that's not less than. So now my null is equal to 0.8 and my alternative is not equal to 0.8. This is a two-tailed test, and this is a special test because, just some things change when I have a two-tailed test. This is the only kind of test such that the words for the claim kind of match the null rather than the alternative. Most of the time, the words are matching the alternative, right? In this case, the words, right, are matching the null. So that means when I get to my interpretation, I can interpret it two different ways. I'll show you that when we get there. Let's talk about number of successes. So 82.8% of 198 had success. So 0.828 times 198, right? If I want a percent of a number, I'm going to change the percent to a decimal and multiply. So 0.828 times 198. Now the thing is, so I got 163.944. 163.944. Now the thing is that I can't have a decimal amount of a person, and x represents a number of. This has to be a whole number, so you're going to have to round to the nearest whole number. And if you were rounding x, then you might have slight error if you're using the calculator trick, because it asks for x, and your x is not going to give the exact sample proportion as if you were doing the formula where you would have the exact proportion. But not a big deal, you'll still come to the same conclusion and such. Let's find all these pieces. Test statistic, which is a z-score. P-value, critical value, which is a z-score. If you want to go ahead of me, you can. Can I go and do the critical value without showing my work? This is, actually no, I need to show my work, because this is a separate kind of scenario. My critical value, so what happens here? I have a two-tailed test. So therefore, I have two tails. I have two rejection regions, a rejection region in the left tail and a rejection region in the right tail. So something did change, right? Instead of one rejection region, now I have two. Alpha is the area of the rejection region, which is split into two tails. So half of it goes here and half of it goes here. So the area in the right tail is 0.01 divided by 2, or 0.005, and same thing over here. And this is the only time that I have two critical values, because I have two rejection regions. So let me do that real fast. Let me find, it's not hard to find the two critical values because they're both the same. Inverse norm. I'm going to find the left-tailed one because it's easier. So 0.01 divided by 2 is the area in the left tail. I could literally just type that and it will do it for me. It's the standard normal distribution curve. So I'll get my left-tailed one. Negative 2.56 is my left-tailed critical value. Negative 2.56. So negative 2.56. So I have a critical value here in the left tail, negative 2.56, and a critical value here in the right tail, positive 2.56. It's a symmetric curve, so they're the same number, but opposites. So again, what changed? When I have a two-tailed test, alpha is cut in half, and now I have it in each tail, half of it in this tail, half of it in that tail. Let's actually find the test statistic and the p-value. So I'm going to go to stat and tests down to 1 prob z test using my calculator. And p0 is the value on the null. So what is that? Equal to 0.8. So 0.8 is p0. X we had to approximate, which was 164. And then my n, my sample size, was 198. And then it's a two-tailed test, right? Make sure that I have, not equal to highlighted. Go down, and I want you to notice p hat is 0.82828. You see, this is not exactly the same sample proportion as what is given here, but it's approximately the same. That's why if you are using the calculator trick, you might have a slight error in your results, just based on the fact that you had to approximate x, but it's still pretty close. So my test statistic is 0.99. My p-value is 0.3198. Let me write that down. And then we'll come to a conclusion. So what was it? My test statistic was approximately 0.99. My p-value was, what was it? 0.3198. See, but looking at this, I can already tell what we're doing. What are we doing? Are we rejecting or failing to reject the null? My conclusion. Let me double check my inverse norm. Did I make an error? Did I write down the wrong thing? Double check. Yeah, sorry. Negative 2.58 and positive 2.58. I'll put 5.6. Double check. Thank you very much. Don't make that mistake. I don't know why I saw 6. 2.5858, right? Technically, it doesn't make a difference for this problem only because of the fact that the test statistic is so far away from the critical value, but sometimes they are pretty close, so you don't want to make that error. Thank you. So my conclusion is, if I'm using the traditional method, the test statistic is located closer to the center, so like here, which is not in the rejection region. So I am failing to reject the null based on that. And then if I'm using the p-value method, the p-value is way bigger than alpha. Alpha is 0.01 and the p-value is 0.32. So therefore, again, I fail to reject the null. And then I'm going to steal this so I don't have to retype it. And if I'm failing to reject the null, now there's 2 ways that I could type this up. Actually, let me do it here. Based on the fact that it's a two-tailed test, 2 ways that I can interpret this. So I'm going to type it first, and then you guys, hopefully, I'm going to stay consistent with what I've done before. If I'm failing to reject the null, then there is insufficient evidence to support the alternative, but my words have to match this, which says that it's not equal to. So there is insufficient evidence to support the claim that, let me go to my problem again, that the percent of patients who stop smoking when given sustained care, the proportion, I should say, the proportion of patients that are given sustained care is not equal to 80%. Versus there is sufficient evidence to support the claim that 80% of patients who stop smoking, the proportion of patients that are given sustained care that stop smoking when given sustained care. And there is insufficient evidence to support the claim that, I'm going to pull that from again, 80% of patients stop smoking when given sustained care. 80% of patients stop smoking when given sustained care. Okay. They kind of say the same thing in different ways. Remember that I said that a two-tailed test is the only type of test such that the words match the null hypothesis rather than the alternative, versus all the other type of tests, the left-tailed, the right-tailed test, the words, they match the alternative. So if I am failing to reject this, I'm not rejecting the null. I'm not rejecting the null, failing to reject it. That means I'm supporting it. There's sufficient evidence to support this, and supporting this says that it's equal to 80%. That's one way to say this. If I'm saying that I'm failing to reject this, I'm failing to reject the null, so I should be able to support the alternative. Failing to reject the null is not supporting the alternative. Failing to reject the null, there is insufficient evidence to support the alternative, which says that it's not equal to. So again, failing to reject the null, so I can support the null, says that it's equal to. Failing to reject the null says that I cannot support the alternative, which says that it's not equal to. So I can say it two different ways. There's insufficient evidence because I'm failing to reject the null. There's insufficient evidence to support the claim on the alternative, that the proportion of patients that stop smoking when given sustained care is not equal to, right? I'm not supporting the alternative. Not equal to says the alternative. There is sufficient evidence to support the claim that it is equal to 80%, right? I'm failing to reject the null, so I'm supporting that 80% of patients stop smoking when given sustained care. So the two-tailed test is funky. Two critical values, two rejection regions, alpha split in two, and then you can interpret it two different ways just based on the verbiage. I don't care which one you use. My math lab might, basically kind of force you to be able to interpret both ways, but they both say the same thing.